All right, so exponential functions are what we've been learning about all week, right? What does the graph of an exponential function look like? It looks like a curve. Good, take a point. Now, the definition of an exponential function is this. An exponential function is a function with an exponent of x. It has an exponent of x. Alright, so an exponential function has very specific characteristics. Do you guys remember that we had two types? What were they? One of them started with a G, one of them started with a D. One of them was getting bigger, so what's that called? It starts with a G. It was a growth. We wrote this down. I need you to remember things. Okay, so growth and decay. Good, take a point. So now an exponential function looks like this. We write it as f of x equals a times b to the x. Now this right here is called a starting value. And it's really just a coefficient to your function. Do you guys remember what kind of notation this is called? It's called function notation. We did this. I taught you this. I was there. Alright, so this is our starting value. This guy right here, the B, that determines whether it's a growth or decay. Now, on our first one that we did, the one where we were cutting strings, does anybody remember what the growth equation was? Was it a whole number or a fraction? When it was a growth. A whole number. Take a point. So when B is greater than 1, it's a growth.
Hey, is that starting value pointing to A or the whole? My bad.
We had like whole other conversations in between that, so you could have been paying attention during that part.
Gosh.
Yeah, I know. That's real. Alright, so now if it's a fraction, that means that it's between this. It's greater than 0 and less than 1. This is called a decay. And then this number out front, if it's negative, that flips it over, turns it around. It does all kinds of great things to it. Are we ready to show what an example would look like? Okay. So, it has to have x as an exponent, correct? That's what we wrote down up here as our definition. So I could say f at x equals, and if I wanted it to be a growth exponential function, it would have to be greater than 1. So pick a number greater than 1. And it has to have x as an exponent, so we're going to write x. That is an exponential function. Look at us go. Now, it's a baby x up top. It's not x as a variable sitting down beside it. Does everybody understand? This is an exponent. Now, the graph, does anybody remember what the graph would look like? It would curve. If it's a growth, would it curve up or be going down? Up. Now, Did ours the other day ever cross the x-axis? No. It got really, really close, but it didn't ever cross it. Now, what would a non-example be? One that's not an exponential function. Jackson?
1.
1, yes. So y equals 1 would not be an exponential function. Great job.
No, just 1, because it wouldn't be any function. It would just be a number.
Yes. Okay, so 1. Good. Take a point for your team. Can anybody give me another non-example? Give me like a function. We already have y equals 1. Give me a function with a variable. Y equals 2x would not be 1. Good. What about a graph? Good, take a point. What about a graph? What would a graph look like that is not an exponential function? A straight line. Awesome. Take a point.
Or maybe a wavy line.
A wavy line? Yeah. So you could have one, I'm going to draw it on the same graph, that looked like this. That's not an exponential function. That's actually the graph of cosine.
No, wait, what about what about just like a big hump?
That's a quadratic.
Oh.
And that's also not an exponential function. Yeah. It would look like this. Y equals x squared. That's not an exponential function because the exponent is 2, not x. Are we ready to do some examples and work it out? Yes, no, maybe so. It's pretty easy. You will need a calculator, so if you don't have a calculator, I would go get a calculator. All right, turn your page to 14B. All right, 14B. So there are 4 steps to graphing an exponential function. So let's write at the top how to graph. And let's try to write neatly because we're on graph paper and it helps us write neatly, right? It's the whole point of having these books. Let's try. All right, so the first one, create an XY table. Do you guys remember what that looks like? It was a t-table. And what values did we pick to start with? Do we choose our x values first or our y? X. Always choose x first. Good. Take a point. So we would pick 0, 1, 2, 3, 4. The next thing you do, step 2, is use your x to find y, which means we plug in. So we would take these, we would plug these into our function. Then we would get our y values. Our third step, what do you think we would do once we had both x and y? We would graph it because we're graphing. Man, oh man, it's like we forget from day to day. It's like we're in a room full of Dories. And the last thing you do is sketch the graph. Are you guys ready? Alright, so we're going to start by doing 2 growth functions, and then we're going to do 2 decay functions, and then we're going to add in some numbers and have fun. On Monday, we're going to play a card game to match them up, so you're going to need to pay attention. Are you ready? Example 1. I want you to graph f at x equals 3 to the x power. Now, why is this a growth exponential function? Because it's greater than 1. Good, take a point. Now, what I want us to do is I want us to create a table that looks like this. We have x, and then we have y over here. And right here in the middle, we're going to show what we plug in. We're going to actually show our work on this. So I would always pick small x values. What do we want to pick? 0, 1, 2. We could do 3 if we wanted to, but let's not go crazy. Now, are we going to plug these values in for x or for y? For x, because they're under the x column. So we're...
I'm sorry, wouldn't it also be kind of easy if we did -1, 0, +1, and +2?
You can do -1 as well, yeah. Alright, so then you're going to plug in 0 for x on the first one. What would I plug in on the second one? You would plug in 1. What would I plug in on the third one? 2. Does everybody see what the middle column is for? Once we practice enough, you won't have to do this, but I want you to show your process. Now, what is anything to the 0 power? 1. Thank all the gods that you remembered that. Take a point, children. What is 3 to the first power? 3. And what's 3 squared? 9. Does everybody see? Yes, these are really easy. You ready to graph?
Yes.
¿Por qué no? What?
You got it.
Okay. Awesome. Okay. This is what my graph is going to look like. X, Y. And we're going to pretend like Miss Asbury knows how to draw a straight line.
Okay.
Alright, so at 0, when x is 0, this is our x-axis, what is our y value? 1. Good. Take a point. So we start at 0, we go up 1, we put a dot. When x is 1, what's our y value? So we're going to go up 1, 2, 3. When x is 2, what's our y value? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, remember, it's a curve. So don't cross that x-axis, but extend it over and curve. What's your last coordinate? 2, 9. Does everybody understand? Ready to do another one?
Yeah.
Do you want to try one without me? Okay, try it without me. Alright, I want you to graph f at x equals 4 to the x power. Ooh, I want to do this one together, the first part, because I want to throw in a negative. Because we're fancy and we can.
See, one of my math teachers a couple years ago said that it was really smart to use -2, -1, 0, 1, and 2.
Mm-hmm.
So, I don't.
That's when it's linear.
Oh.
Alright, so -1, 0, 1, and 2 is what we're going to use this time. So our process column, which is what's in the middle, we're going to write 4 to the what? What's the first one we're going to write? 4 to the -1. And then we're going to write 4 to the what? And then 4 to the? And then 4 to the? Awesome. Because our function is 4. Alright, now on the first one, does anybody remember what we do when we have a negative exponent? We do. Take a point. We flip it. So what's this going to become? If we flip it over, what's on top now? 1. So it's 1/4. All we did was flip it. It's 1/4. Alright, what's anything to the 0 power? 1. What's 4 to the first power? What's 4 squared? 4 squared is 16, tater tot. I'm sorry?
What's that number under the line?
Right here? 1/4. Yes. Alright, now, how would we graph -1 and 1/4? Yes.
Why are you making your graph like
Because we're only graphing up above, so we don't have to go all the way down. You go left 1, and then you'd go up a baby bit, right? So when it's a fraction, you can't be exactly precise, so we just go left 1 and then up a baby bit. Can we be precise on 0, 1? So let's go up 1. What comes next? And do we have room for 16? Nope. So let's just sketch it. Dun, 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 dun. Is it ever going to cross the x-axis? No. Do not cross the x-axis.
But it will get smaller and smaller.
Yes, but it won't cross the x-axis. Okay, now can you do one without me? For realsies. Alright, I want you to use -1, 0, 1, and 2. I want you to use that negative. And what do we do on a negative? You flip it. Alright, mine's going on 14C because I'm out of room. Alright, example 3. I want you to graph y equals 5 to the x power. Does it matter that I put y instead of f at x? No, they're the same thing. Let's go, let's go. Don't die on me. Okay.
That has no sub, so I gotta go get the report cards out of it.
Have a great time.
I'm gonna try.
I'll be here.
It should be fun.
Yeah. All right, guys. So -1, 1/5. Did you go left 1, up a baby bit?
Yep, I did.
And then 0, 1. Did you just go up 1?
Yep, I did that.
1, 1, 2, 3, 4, 5.
I did that.
And then if you don't have enough room, you just connect, right?
No. I almost made my line going up in this.
It's okay. All right, now let's look at what's going to happen if we have a fraction. It's going to be crazy. All right, so if I say, I'm sorry, I thought I was teaching. I am. So 1/2 to the x power. We're going to use 5 numbers this time. We're going to go crazy. All right, you still do the same thing. Don't be freaked out just because it's a fraction. Fractions are friends, not food. So we're going to start with -2 this time. We're going to say -2, -1, 0, 1, and 2. And we're going to raise that 1/2 to each of those numbers. -2, -1, 0. Am I teaching? Who is talking? Because we got to stop. All right, anytime we have a negative exponent, what do we do? We flip it. So then this would become 2 squared. And what's 2 squared?
4. Because, yeah.
Does everybody see what I did? All you do is flip it. Okay, baby. Do you see my fraction right here? I flipped it over, and then you make your exponent positive. That's all you do. That's all I did was I flipped 1/2. And when you flip that over, it's 2 divided by 1. And remember, we don't have to write the 1, so we just wrote 2 squared. Better now? All right. Now, 1/2 to the -1. What do we do when we have a negative exponent? We flip it, and that becomes 2 to the first power. Is everybody with me on what I just did? And what's 2 to the first power? 2. Now, what's anything to the 0 power? 1. What's 1/2 to the first power? 1/2. And what's 1/2 squared? 1/2 times 1/2 is? No, that's adding. So if I say 1/2 times 1/2, remember we do 1 times 1 and we get? 1 times 1 is? 2 times 2 is? Okay. Y'all scaring me. Maybe. If you can't tell me that 1 times 1 is 1, we might be in the zone. All right, graph it. I need you to stop laughing for no reason because you need more attention. Now, homework. I want you to graph y equals 6 to the x. Y equals 1/3 to the x. And the last one I want you to do, y equals 2 to the x plus 1. And finish graphing example 4. Now, if you have questions or you're confused, when should you come see me on Monday? 0 period. Oh, potatoes. Should you also maybe watch the video?